Hello everyone. In this video we're going to do one example finding the equation of a plane. And I've got it below at the bottom. I just want to remind everybody what the equation of a plane is. It's ax plus by plus cz equals a number d, where a, b, and c are the first, second, and third component of a vector which is normal to the plane. And that and a point on the plane is all we need to determine the equation, and I like to refer to that as a general equation of the plane. Alright, in the previous video we discussed the point normal form and also the parametric description of a plane. Alright, now let's do this example down below here. So we want to find an equation of the plane that contains the point 2, 0, negative 5, and the vectors u, which is 1, 1, negative 1, and v, which is negative 1, 1, and 2. So keep in mind, we're shooting for an equation of this form, ax plus by plus cz, where the coefficients a, b, and c are the coefficients of some vector which is normal or orthogonal to the plane. And there's no exact one equation. Depending on how you do this, my answer might be a scalar multiple off from your answer, but their graphs are going to be the same. Alright, so our job is to find a normal vector. That's our starting point. Alright, so that's what we need to do first. Now what we're given is two vectors u and v. I'm just going to copy those down here, that are in the plane, that lie in the plane. And we need to go through our process of finding the cross product of those vectors. You could do u cross v, you could do v cross u. Alright, I'm going to do u cross v, and I'm going to define n to be the result of what we get when we do the cross product of u and v. Alright, remember, the cross product is a vector which is orthogonal or perpendicular to both the vectors u and v. Alright, when we do a cross product, we think about this as a 3 by 3 determinant where we put I, j, and k in the top row of that matrix. Alright, so what I like to do is write my two vectors down and then put ij and k across the top. And then for us to find out u cross v, we're going to think about just looking up above. I'm going to erase this in a minute, and deleting the first row and first column, and computing the resulting 2 by 2 determinant. Alright, which will be 2 minus negative 1. Just erase those. Alright, so our first component, we're multiplying 2 and 1 and times 2. Alright, so we're doing this multiplication minus this multiplication. Alright, so it's going to give us 2 minus negative 1. Alright, and then we do the opposite of what we get by deleting the middle column in the first row and multiplying that by the vector j, which means that's our middle component. So that's going to be 2 minus 1 in that spot, in the middle component. So we're going to have 2 minus 1 here. And then the third component we get by deleting the first row, crossing that out, and crossing out the last column. And for that, then we're going to do 1 times 1 minus negative 1 times 1. Alright, and doing that, what do we end up with? We end up with there 1 minus negative 1. Alright, so simplifying that, what is our normal vector going to be then? What is the normal vector we're going to use? It's the cross product of u and v, and then just simplifying these components, we get 2 minus negative 1, which is 3. The opposite of what we get, this is going to be 2 minus 1 is 1, so we're going to get negative 1 is the middle component, and then 1 minus negative 1 is positive 2. Alright, now we're going to take those components and we're going to plug those into the equation for the plane, ax plus by plus cz equals d. Alright, so let's do that now. Okay, so I'm just going to rewrite the equation out. We've got ax plus by plus cz equals d. We now know that we're going to plug in 3 for a, negative 1 for b, and 2 for c in our equation. So we're going to have 3x minus plus negative 1y, which is minus y, plus 2z equals d. Alright, now the last thing we need to do to finish this is to find that constant d in the equation. And to do that, we're going to plug our point in, and our point is 2, 0, -5. All right, so the point P we were given was 2, 0, -5. And keep in mind that those are x, y, and z of a point. And if a point is going to be on the graph of an equation, it must satisfy the equation. All right, so we are going to plug those in for x, y, and z to then get what d is equal to. So 3 times x minus the y component of the point plus 2 times the z component of the point must equal whatever this number d is, and therefore we're going to find out what that is by plugging those values in. So we're going to do 2, 0, -5. Simplifying gives us 6 minus 10. So what is d? D comes out to be -4. All right, so there's our equation. Then we just got to plug that back in up above there for d. So we've got our equations 3x minus y plus 2z equals -4. All right, and that's it. If that's all we were asked to find, done. All right, now what I want to do is a little bit additional to that, and I want to plot that in Maple. There's two ways we can plot this in Maple. One is to use the plot 3D command. All right, we have these two options. We're using plot 3D or the command implicit plot 3D. And I'll show those both in a moment here. But with plot 3D, if you're going to use that one, you have to solve for z. So that's the downfall about using plot 3D. The upside is that the graph comes out a little bit better in Maple. So let's take a look at that for a moment. All right, so if you remember from the last video, I plotted that plane, and it's going to have that same graph. All right, in the last video. Now, I'm just showing a couple of things here. Maple will solve equations for you and solve for variables. So what I did here was I typed in the command solve, put in the equation we determined, and said, okay, Maple, solve that for z. Here was the result. So I copy and paste that and put that into a plot 3D command. And then, what are we looking at? It gives me a plane. All right, now, how do we know that we have the right equation? Well, we graphed in the previous video the equation, or the plane that contained those two vectors u and v, containing and included that point. All right, so if we've done this correctly for this example, when I plot our previous graph and this graph on the same axes, we should have the graphs coinciding, and we do here. All right, so the two graphs coincide with each other. All right, the other thing we could do is to use the implicit plot 3D command. Okay, I had to move my screen move my viewing window for a moment. So the other way to do this would be to use implicit plot 3D, again, no spaces, all lowercase, and for there you just type the whole equation in, so it's got the equal sign in there, but you have to put in an x range, a y range, and a z range, and if I plot that, it's going to have a similar looking graph. If I put those, just to check it again that we got the right equation, if I put that together with the original plot, we've got the graphs coinciding. All right, again, similar, but this one comes out a little bit busier. Implicit plot 3D, that command requires Maple using some of its solver features inside there, so it's a little tougher for it to give a smooth graph versus the plot 3D command, where that's just evaluating an expression, right? So it's easier to plug numbers into an expression and compute the outputs versus solving equations, which implicit plot 3D will do. All right. So just to recap, what did we find? What did we do with this example? We found the equation of a plane, and to do that, we have to find a normal vector. All right, and we were given two vectors in the plane, and therefore their cross product will give us a vector normal to the plane, and that will help us, that combined with the point that lies in the plane, will help us determine the equation. And that's it for this video.